Hello everyone, my name is Wei Kou. I graduated from the Department of Electrical and Computer Engineering in University of Connecticut. My major is renewable energy and power network. By that, I'm talking about today is how to set up a cloud-based electric load forecasting with Bigquery machine learning platform. In this presentation, I will talk about the Bigquery machine learning tools, including Bigquery, Data Lab, and Data Studio. Then I will show how to create an online electric load dataset. Also, I will introduce Bigquery machine learning steps. Finally, I will show you a case study for electric load forecasting, which includes feature engineering, k-means clustering, and so on. First of all, what is Bigquery and why would you want to use it? Bigquery is a serviceless data warehouse that allows you to store massive amounts of data. And then it provides a centralized place to put all of your data and query them with standard SQL statements. Then, after the data is being fed to the analyze level, Bigquery machine learning enables users to create and execute machine learning models in the cloud machine learning engine by using SQL queries. The goal is to democratize machine learning by enabling SQL practitioners to build models using their existing tools and to increase development speed by eliminating the need for data movement. Also, the Data Studio tool is combined closely with the Bigquery platform. Google Data Studio 2 is the data visualization layer added on the top of Google Data Stack. The Data Studio works best if the organization already has Google's Bigquery platform for data warehousing and had an existing workflow for data cleaning and transformation. After setting up the Cloud Data Lab, you will have this playground for all your data analysis and processing needs, and it's already wired up with your data from Bigquery. Another important tool is Cloud Data Lab. I work on machine learning problems and use Python notebooks. The Data Lab basically provides you a Python notebook with unlimited computing resources. To set up a Cloud Data Lab, you just need to activate a shell session in Bigquery platform. Let's talk about create online electric load dataset. We are just going to upload a CSV file to cloud storage and then connect it as a table to Bigquery. This is hourly load data of the power supply company of the city of Johor in Malaysia, generated in 2009-2010. This data has been used in a paper in the International Journal of Energy. You can download the data from this data source. After inputting the data to the Bigquery, the schemes will be automatically detected. That is month, day, year, hour, minute, day, noon, that is in the morning or in the afternoon, and the temperature and the related load records. Then we will use this data lab to predict the future load. Then we are going to introduce the three main steps of Bigquery machine learning for electric load prediction. The first step is to create a machine learning regression model. We are going to run the query that contains the create model statement to train the model using the data retrieved by your query select statement. The create model clause is used to create and train the model named cloud-based electric load prediction. The option clause refers that you are going to use the model type that is linear regression, which is going to build a linear relationship between the input data and the output data. We cite the input label columns as load. That is, we are going to predict the load based on the input scheme variables. All the input scheme variables is retrieved by the select clause, which refers that you are going to retrieve the month, day, year, hour, temperature, load from the dataset which is under the Cloud-Based Electric Load Prediction project in Bigquery. The where clause limits the training data, which is year scheme equals 2009. Although script is running in the data lab, the query takes several minutes to complete. After the first iteration is complete, your model appears in the navigation panel of the Bigquery web UI. After creating your model, the next step is evaluate the machine learning regression model. You evaluate the performance of the regression model using the machine learning evaluate function. In this function, we can see the topmost select statement retrieves the columns from your model. And the from clause uses the machine learning evaluate function against your model that is in the cloud-based electric load prediction project. And the query's nested select statement and from clause are the same as those in the create model query. The where clause limits the number of tables scanned by the query. In this evaluation model, we will going to use the year equals 2010 records to evaluate the regression model. Now that you have evaluated the model, and then the next step is to predict the outcomes. We will going to predict the electric load in 2010. The query we are going to use is machine learning predict, and inside of this function, we will select the same schemes and from the same dataset as we used in the machine learning create model. And then we will have a new column named the predicted underscore label. That label is equal to the label set in the create model step. In our case, is the load scheme. We also did electric load feature engineering for the several schemes of our raw data. Based on this correlation matrix, we found that the temperature has the highest correlation with the predicted value, the column load. So we will separate the schemes into two cases. One is the case with all the schemes include month, day, year, hour, temperature. And in the second case, we would only use the temperature to predict the load. The case study. The results firstly is showing the evaluation results of two models. One is without feature engineering. We will use all the schemes in the raw data, that is month, day, year, and temperature, and so on. And the other model is after feature engineering. We will only use the temperature scheme, which has the highest correlation with the predicted load value. Comparing the two results, we can find the important metric in the evaluation results is R2 score. The R2 score is a statistical measure that determines whether the linear regression predictions approximate the actual data. 0 value indicates that the model explains none of the variability of the response data around the mean. 1 value indicates that the model explains all the variability of the response data around the mean. So we hope the R2 score could be as high as possible. Normally, if it is higher than the 0.6, we can say it's a valuable prediction model. Then we also run the Python machine learning package scikit-learn in the data lab and use the same model as the linear regression, and with the same raw data, we can find the model evaluation coefficient of determination, that is R2 score, is 0.6, which is very close to the Bigquery machine learning evaluation results. We also import our machine learning prediction results into the Data Studio to show the prediction results graphically. The red line in this figure represents the raw data in our test dataset. The blue line means the model without feature engineering, and the green line is the results of the model with feature engineering. That is, only the temperature scheme is included to predict the load. Based on the results we can see, with the feature engineering, the final model prediction results could have a better performance than the results without feature engineering. We also did the electric load data clusters. We generated the k-means clusters model of the dataset with the features month, day, year, hour, load, temperature, and the number of clusters we choose is 4. Case 1, we only use the 2009 records. For case 2, we use the 2009 and 2010 records together. Okay, so as we can see, the Davis-Bowden index for case 1 is lower than case 2. The mean square distance for case 1 is smaller than case 2. This result reflects that if we just choose 4 clusters, case 1 will be better than case 2. If we want to improve the performance of case 2 for clustering, we may need to increase the number of clusters. For the summary of our work, we compare the Bigquery machine learning with the scikit, which is a Python machine learning package. We can see the Bigquery machine learning currently only have 4 kinds of models, which is linear regression, logistic regression, k-means, and TensorFlow. But definitely, the Python scikit machine learning model definitely has more choices on models. But it still has some limits on handling the string type feature, like the AM and the PM in the electric load dataset. But those string type feature is compatible in Bigquery machine learning platform. In our case study, we fully used the Cloud Data Lab to analyze and do the machine learning for the electric load prediction. We compare the Data Lab and Code Lab as two similar tools. Data Lab allows you to analyze data using Google Cloud resources. You can take full advantage of scalable services such as Bigquery and machine learning engine to analyze, manipulate, and visualize data. You can use it with Python, SQL, and JavaScript. While CodeLab is a tool for education and research, it currently only supports Python. Its ability to support cloud-based big data analysis is limited. This is my today's presentation. Thanks for listening.